Hello students, myself Krina Dayani welcomes you all of you at AriserTalent. So how are you all? I hope you are doing absolutely good. So today we are going to discuss about some of the NTSE questions that are important and that may be asked in your previous year exams from NTSE and few Olympiad exams. So let's discuss some of the questions that are from your chapter electricity. So in this sequence we have our first question, that is, in the given circuit diagram, the value of resistance X is in ohm when the bridge is balanced. So you have to determine the value of X. Now, this is the Wheatstone bridge you have provided here. You can see that 4 resistances are arranged in the form of a quadrilateral here. So this is our Wheatstone bridge. This is our Wheatstone bridge and you have to determine the value of unknown resistance X. What you have to find out? You have to find out the X. Now, in Wheatstone bridge, the bridge is said to be balanced when the resistance connected in the adjacent arms is having the equal ratios. Suppose I am denoting this resistance as R1. This will be our R2. Suppose this is, I am starting from here. R1, R2 and this is our R3, R4. R1, R2, R3 and R4, you can name it as you like, but I am denoting it as R1, R2 and this is our R3, R4. Now, if the resistances in its adjacent arms will having a same ratio, we can say that the condition is a null deflection. It means the bridge is balanced. So, when the bridge is said to be balanced, bridge is balanced when this condition occurs. What is the condition here? R1 upon R2 will be equal to R3 upon R4. In this condition, the bridge is said to be balanced. Now, you can see that the value of resistance R1 equal to 10 ohm, R2 equal to 4 ohm, R3 equal to 10 ohm and R4 you have to determine here, but you can see that equivalent resistance 8 is connected with here and you have to determine the value of X here. Now, the bridge is said to be balanced when both these ratios are equal. So, this is our 10 upon 4 and you have to reach at the point that R3 upon R4 also came out to be 10 upon 4. So, this is our resistance 8 ohm. Now, how much resistance will be connected in parallel? So, the entire system will give you the resistance of 4 ohm. So, I am connecting the resistance of 8 ohm here. So, 1 upon 8 plus 1 upon X will give you the value of 1 upon R4. And what you have to take on the R4 here, you have to determine the value of R4 equal to 4 ohm because in this case the bridge is said to be only balanced. So, 1 upon 8 plus 1 upon X is equal to 1 upon 4. This is the equation I am getting here. 1 upon X is equal to 1 upon 4 minus 1 upon 8 and it came out to be 2 minus 1, that is equal to 1 upon 8 and 1 upon X equal to 1 upon 8. So, what will be the value of X here? The value of X here will be 8 ohm. So, what you have to do? You have to connect the resistance X equal to 8 ohm. So, the conditions R1 upon R2 and R3 upon R4 will be satisfied. So, why I am writing the R4 equal to 4 ohm? Because 10 and 10 are provided here and you have to write 4. So, here also we have to write the 4 in order to make the bridge balance. So, the value of X came out to be 8 ohm. So, I can say that here the option number B will be our correct answer. So, this is about a question from Wheatstone bridge. Just copy this solution from here so we can proceed to the next part. Now, let's move to the next question in this sequence we have. In the following figure, you have to determine the equivalent resistance between point A and B. You have to determine the equivalent resistance between point A and B. So you can see that this is our 3 ohm and again this wire is connected from here. This is 3 ohm and again there is a separation of this wire from here. So we can say that 3 ohm and 3 ohm must be connected in parallel combination. So this circuit will be like this. This is our point A, this is 3 ohm, this is 3 ohm and this is our 3 ohm and they can be connected like this. 3 ohm and 3 ohm. Now, if you want to determine the equivalent resistance between point A and B, as we can see that this is a parallel combination here. This is our parallel combination, and for parallel combination 1 upon RAB, that is R equivalent, will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. It is equal to 1 upon 3 plus 1 upon 3 plus 1 upon 3 and it came out to be 3 upon 3. So 1 upon RAB equal to 1. So RAB will be equal to 1 ohm. So what is the equivalent resistance between point A and B? It came out to be our 1 ohm. So let us check the options here. A. So the resistance in ohm will be 1 ohm. So this is a very simple question from the combination of the resistances, but only you have to determine whether they are in series or parallel. So just copy this solution from here so we can proceed to our next part. Now, next question in this sequence will be in the circuit diagram shown in the figure, the current flowing through 5 ohm resistance. So you can see that here is current I, that is equal to 2.1 ampere flowing in this circuit, and you have to determine the current flowing in this arm. You have to determine the current I in this 5 ohm resistor. Now, you can see that these resistances are also connected in the form of the Wheatstone bridge. So these will be in series, these will be in series, and the combination will give you the parallel one. So I can found out here that resistance in upper arms resistance will be 8 plus 2 ohm and it came out to be 10 ohm. This is our lower arms and the resistances in the lower arms will be 20 plus 5. So the resistance in lower arms came out to be 20 ohm plus 5 ohm, that is equal to 25 ohm. Now, this combination connected with this combination will give you a parallel combination. So 1 upon R equivalent will be equal to 1 upon 10 plus 1 upon 25 and it came out to be 50. 5 plus 2, it will give you 7 upon 50 and R equivalent will be 50 upon 7 ohm. So this is what? This is the value of resistance I am calculated from here, that is equivalent resistance. Now, you can see that current of 2.1 ampere is flowing in that branch. So, if I have to calculate the value of voltage from here, the voltage will be calculated only by the Ohm's law. So, V equal to IR, I is 2.1 and what is the value of R we have calculated? That is 50 upon 7. 1 0 will be cancelled by 1 0. 7 3 are 21 and it will give you 15 volt. So, the value of voltage will be 15 volt here. So, this is our voltage, this is our R equivalent. Now, what you have to determine, actually you have to determine the value of current in the 5 ohm resistor. So, if I have to find out the value of current in the 5 ohm resistor, how can I determine that value? I will calculate I will be equal to V upon R. I equal to V upon R. What is the value of voltage here? That is 15 and the resistance is 5 ohm here. So, current came out to be 3 ampere. But we can't say that 3 ampere current will be flowing in that part only. You have to determine the value of current in this system. So, the value of current came out only by subtracting the respective values. So, what you will do? You will just subtract 3 from the given value and you will determine the value of current in the 5 ohm resistor here. So, let's move to the next question in this sequence we have. The material of the heating element in an electric press will be. So, when you are obtaining any electric press, it must have a high value of the melting point and a low value of the specific resistance. So, let us check the options here. High melting point, high specific resistance, high melting point and low specific resistance, low melting point and high specific resistance, low melting point and high specific resistance. So, it must be high melting point and low specific resistance for electric press. So, we can say that option number B will be our correct answer. Now, this is the theoretical question we have. Let's move to the next part we have. 1 volt is equal to . So, actually our 1 volt is a value of the potential difference when the current flowing in the circuit will be 1 ampere for a particular amount of time. So, 1 volt will be basically equal to, if I am comparing in the units of Newton, Joule and Coulomb, so it must be equal to 1 Joule plus Coulomb, because Coulomb is a unit of charge we have and Joule is the unit of energy we have. So, how you will arrive at this unit? Let's check the here. 1 volt will be equal to V equal to IR, and if I am talking about work done will be VIT. So, work done will be our VIT, and if I am going to calculate the value of the current is determined as charge per unit time. It means charge flowing in a unit time. So, when you divide both these equations, what you are getting here, you will get the unit of work as a joule and the value of the current will be coulomb, which will give you the value of the 1 volt. So, which is the correct option here? The correct option here will be option number C. Now, let us move to the next part of the question we have. On a bulb, it is written as 220 volt and 60 volt, you have to find out the cutoff resistance of the bulb and value of the current flowing in the bulb. So what we will write first, we will write the given conditions here. The given conditions are V equal to 220 volt and power equal to 60 watt. What you have to determine, you have to calculate the resistance of the bulb. So for the power, we are having a formula that is equal to V square by R. This is the formula for power. So the resistance came out to be V square upon P, that is equal to 220 into 220 upon 60. 0 will be cancelled by 0. It is 3 here, it is 11 here. So it came out to be 2420 upon 3. On solving this, what I am getting here, 806.6 ohm. So this is the value of resistance I am getting here. So this is the value of cutoff resistance here, and you have also determined the current in the circuit. So from Ohm's law, I will be equal to V upon R. Voltage is 220 and resistance we have calculated approximately equal to 806.6. So the value of current from here will came out to be approximately equal to 0.2. It will be equal to 0.2. So let us check the options here. 806.66, this is our resistance we are getting, and 0.27 ampere, that is the value of the current I am getting here. So the option number A will be our correct answers. So this is again a question that is formula based, dependent upon the formula of power, and again the Ohm's law is applied here again. Now let's move to the next question in this sequence we have. An electric iron draws a current of 15 ampere. So the given condition is I equal to 15 ampere. From a 220 volt supply, value of voltage is 220 volt. What is the cost of using iron for 30 minutes every day for 15 days if the cost of 1 unit power is 2 rupees? So time is 30 minutes and number of days we are using the iron is 15 days. 15 days we are using and we are given a cost of 1 unit. Cost of 1 unit is 2 rupees. Now, you are provided with current and voltage value. So what you have to determine? You have to determine the cost of using iron. So what I have to calculate? I have to calculate the power in this question. So power must be calculated by a formula P equal to VI. What is the value of voltage here? 220. And what is the value of current? It is 15. So it is equal to 0, 0, 15 to our 30 and 3, that is equal to 33 watt, 3300 watt. So 3300 watt, I can write it as 3.3 kilowatt. Is it clear? I have divided the equation just number by 1000. So we will get the power in kilowatt. So this is our power in kilowatt. Now you are using your iron for 30 minutes for the number of days equal to 15. So this time must be converted into hour. So minute will be converted into hour by dividing it by 60. So I am getting here 1 by 2 hour. Now you have to determine the cost of using iron. Now the value of power is 3.3. You are using it for number of days, that is equal to 15. You are using it for 1/2 hour every day, so 1/2, and the cost of the 1 unit is 2.2 rupees. So it is 2. I am again repeating. Power is 3.3. Number of days you are using is 15 days. You are using it for 30 minutes, it means half an hour, and the cost is 2. So we will multiply all these terms. So 2 will be cancelled by 2. So it came out to be 3.3 into 15. 15 3 are 45. 49.5 rupees. So the cost of using that iron came out to be 49.5 rupees. So let us check the options here. Option number A is the correct answer, as we are getting 49.5 here. So we can say that option number A is correct. So this is again a very interesting question which is entirely different from rest of the questions we have done till now. So just copy this solution from here. A uniform wire, when connected directly across a 220 volt line, produces heat per second. If the wire is divided into n parts and all the parts are connected in parallel across a 220 volt line, the heat produced per second will be. So you are given a wire of uniform length and divided into 2 parts. A wire is divided into n parts, and this is a 220 volt line you have to calculate the heat produced per second. So if I am denoting heat by H, heat is denoted by H, and if we are having n parts, so I am having 1, 2, 3, 4 like this, and we are having n parts, so we have to calculate heat produced per second. You have to calculate the heat produced per second. So the heat produced per second will be H upon n square. It means it must be divided by n square, because for calculating the power we have a formula that is equal to I square R. This is a formula for power, and for calculating the heat of a system according to the heating effect of electric current, it is dependent upon the following factors. It must be dependent upon the R, resistance of the circuit. It is also dependent upon the value of the N, that is the number of resistance connected in the circuit. It is dependent upon the value of I, and it is also dependent upon the value of time. So these are the factors on which the heat produced in the circuit depends. So the heat produced per second will be H upon n square. So here the correct option is our option number B. Now, the next question in this sequence will be, when the diameter of a wire is doubled, its resistance will become. Now what you are provided with, given condition is diameter is doubled. Diameter is doubled. Suppose we are having a diameter equal to D. Let diameter equal to D, radius equal to D by 2. Why D by 2? Because radius will always be the half of the diameter. Now, diameter is doubled. Diameter is doubled, so our new diameter will be 2D. It means it must be double. Radius equal to 2D by 2. So what will be the radius now? Radius now will be equal to D. R equal to rho L by A. So you can see that resistance is inversely proportional to area. It means if area become doubled, resistance will become half. So if I am doubling the diameter, you can see that the radius came out to be D. if you are double the diameter, the resistance will be remain half of that part. So, in this case, if I am calculating the previous resistance, it will be rho L upon pi r square. It will be pi r square, and in this case, if I am calculating the new resistance, that is Rn, it came out to be rho L upon pi, and the radius will be our 2r square. So now it will be equal to rho L pi into 4r square. So you can see that if you are getting the double of the diameter, the new resistance will become the 4 times of the previous resistance. If I am going to calculate the value of Rp upon Rn, if all the terms are cutted, we will get 1 upon 4 here. So the previous resistance will be 1/4 of the new resistance. So the new resistance will be 4 times. So what we are getting? The new resistance will be 4 times of the Rp. It means if the diameter is doubled, the resistance will become 4 times. So this is the equation we are getting here. So you can see that we are getting the value of Rp upon Rn, that is equal to 1 upon 4. So the new resistance will become the 1 upon 4 times as of the previous resistance, because resistance and area are inversely proportional to each other. So what I am getting here? I am getting the resistance 1/4 because the diameter is doubled here. So now let's move to the next question. In this sequence we have Nipper mag is an alloy for. So this is again theoretical type question. You can see we are discussing now. So Nipper mag is actually an alloy which basically consists of iron, nickel, aluminium and titanium. So you have to remember the name of the alloys we have. So the correct option is iron, nickel, aluminium, cobalt, iron, titanium, nickel, cobalt, iron, nickel, aluminium, titanium and iron, nickel, cobalt, titanium. So you have iron, nickel, aluminium and titanium. So this is our correct answer. So this is an alloy for our Nipper mag. So now this is the option number C, which is our correct answer. Now let's move to the next part of the question we have. If 6.4 ampere current flows continuously for 4 seconds. So firstly, I am writing the given conditions here. 6.4 ampere current. I is equal to 6.4 ampere. It is flowing for 4 seconds. Time equal to 4 seconds. Find the number of electrons flowing. So you have to calculate the number of electrons in the circuit. Now, if I am talking about the quantization of the charge. So what will be the quantization of charge? Quantization of a charge can be represented by Q equal to Ne. Or if I am going to write about the formula of I, it is equal to charge flowing per unit time. This is the formula for current and this is the formula for quantization of a charge. Now, you have to determine the value of N from here. So firstly, Q equal to IT. Q equal to IT. So I can write here current is our 6.4 and time is 4 and it came out to be 25.6 coulomb. Now you have to determine the value of N from here. So if I am going to count the number of electrons that are flowing here, so value of Q I am getting from here equal to 25.6. So I have to determine the number of electrons. So I will determine it by this formula. It came out to be Q upon E. Q is having a value that is 25.6 and 1.6 into 10 raised to the power minus 19. This is the value I am getting from here. Now, this is our value that is equal to 25.6 I am getting from here, and it came out to be, as we have determined, this is from the quantization formula, Q equal to NE, and from this IT I have determined the value of Q, that is the value of the charge, 6.4 into 4, that is equal to 25.6 coulomb in seconds, that is we have to calculate the number of electrons here. So it came out to be, point will be cancelled by point, it will be 16 into 16 are 256. So it came out to be 16 into 10 raised to the power 19 coulomb. So this will be the number of electrons we are getting in this circuit. So the number of electrons that will going to flow in the circuit will be 16 into 10 raised to the power 19. So here the correct option is 16 into 10 raised to the power 19 we have. So this is the correct answer we are getting from here. So just copy this solution from here so we can proceed to our next part. Now let's move to the next question of this sequence. You have to connect the order of resistivity of the material at 20 degrees Celsius. So when we were discussing about the chapter, we know that conductors will have a very high value of resistivity because the conduction is possible only when the resistivity is high. So let us check the order here. Conductor, insulator, alloy. This is a wrong statement because insulators have a very high resistivity. Alloy, conductor, insulator. This will again not possible. Alloy, conductor, insulator. Again this statement is false. So the correct order is, in conductors they have less resistivity. Alloys have medium resistivity and the insulators have very high resistivity. So this will be the correct order of resistivity I am getting here, that is conductors, alloys and insulators we have. Now let us move to the next question we have. Frequency of direct current is. So you know that the AC current which is supplied at our homes will have a frequency of 220 volt 50 hertz, but if I am calculating the frequency of the direct current, it is also always having a frequency 0 hertz. So this point you have to remember here, that the frequency of the DC supply will be 0 hertz. Now let's move to the next part of the question we have. You have to determine the value of equivalent resistance between A and B. So this is again a combination, that is your combination of the resistances you have. Now these two resistances are in series and I can calculate these two resistances in the series. So it will be equal to 2R plus 2R. So I can redraw the circuit as, this will be our 2R, and again this is our point B, and one resistance will be connected here and it is again equal to 2R. So this is the system I am getting here, and this will be R plus R and this will be R plus R, and this is again our R and this is again our R. Now this is the combination I am getting from here. Now you can see that there is a 2 points that are described here, and we have just added the system R plus R and R plus R, which will give you the value of 2R. Now you can see that if I am going to combine these combinations, I will get a parallel combination again. So we can write it as R plus R this will be the combination I will get from here, because there are 2 points, so we cannot disconnect these system here. So 2R and 2R will be in the parallel combination we have. So the LCM I am getting from here is it will be in series. So 2R plus 2R will give you the value of 4R. Now, it will be equal to 1 upon 4R. So, R equivalent can be calculated as 4R 4 plus 4 plus 1 we have, because the LCM will be 4 here and we have the two resistances that are again connected in parallel. So, we can also assume these resistances will be 4 plus 4 plus 1, and what I am getting here? I am getting here 9 upon 4. Wait, this is wrong. So, let's do this question here. Again, you are provided with the combination of the resistances and you have to determine the value of equivalent resistance here. So, you can see that these three resistances are connected in series. So, I can redraw the circuit as this is our point A, this is our R ohm, this is again our R ohm, and this is our R ohm. So, if these resistances are in series, I can write it as R plus R, because series combination we will add simply the resistances here. So, I will get here R plus R, I am getting here 3R. So, this is the series combination I am getting from here, that is R plus R, and it is equal to 3R. Now, you can see that this 3R is in the parallel combination with that R. So, I will calculate RP. RP will be equal to 1 upon 3R plus 1 upon R. So, it came out to be LCM here will be 3R and it will be equal to 1 plus 3. So, 1 upon RP will be equal to 4 upon 3R and the value of RP will be 3R upon 4. So, this is the value I am getting from here. Now, I will redraw the circuit. If I am redrawing the circuit, this is our R and here we will get a parallel combination of the circuit. So, these three resistances will be calculated in the parallel combination as, and these are termed as RAB because we have to determine the equivalent resistance between A and B. So, it came out to be 1 upon R and 3 upon 4R. So, the LCM will be 4R and it is equal to 4 plus 3 here. So, what I am getting here? 11R by 4. So, here we are getting the value of RAB, that is equal to 11R by 4. So, this is the correct answer we are getting here. So, the solution for this question will be R plus 3 by 4R, and we are getting here that you can see that these three resistances will again going to show the parallel series combination, sorry. So, this is our 3 by 4R, this is our 3 by 4R, and if I am gonna add this, RAB came out to be R plus 3 by 4R, and RAB will be 4 will be the LCM here, 4R plus 3R, and RAB came out to be 11R by 4. So, we can say that option number C will be the correct answer here. So, firstly what we have done, we have taken a series combination, then this series is connected with this parallel to get 3R by 4, and if I am going to connect this resistance, you can see that these will again in the series combination. So, what we are getting? We are getting 11R by 4 here. So, this is again a combination of resistances we have. Let's move to the next question we have in this sequence. This is again a very interesting question. when 1 joule of work is done to move a charge of 1 coulomb from one point to another, then the potential difference between the point will be. So what are you doing? You are doing a work of 1 joule. And what is the value of charge here? Charge is 1 coulomb. So these are the given conditions you are provided with. Now, you have to calculate the potential difference between the 2 points in the given circuit. So, the potential difference is actually the work done in moving a charge from one point to another in any electric field. So, if the work is 1 joule and if a charge is 1 coulomb, so you can see that the potential difference will also be the 1 coulomb. So, potential difference is amount of work done in bringing a charge from one point to another. Value of potential difference will be work done per unit charge. Work is 1 joule, charge is 1 coulomb. So we can say that voltage difference will be 1 volt. So which is the correct option here? So our correct option will be 1 volt, 4 volt, 8 volt and 0. So we can find out that the correct option is 1 volt. Now, let's move to the next question in this sequence we have. A certain household has consumed 200 of energy during a month. So, how much energy it is consuming? It is consuming the power of 200 unit. 200 unit means 200 kilowatt per hour. So this is the given condition here. Now what you have to do? You have to determine its value in joule. If I have to determine this value in joule, so what I can do here? I will just convert these into the watt per hour because this is given in the kilowatt and we have to do the conversions here for calculating in the joule second. So, you have to calculate the value in joules. So, value in joules will be 200 and for changing the kilowatt into watt, I will multiply it by 1000 and for changing the hour into seconds, what we will do? We will multiply it by 3600. Why 3600? Because 1 hour equal to 60 minutes and 1 minute equal to 60 seconds we are getting here. So, it came out to be 36 towards 72 into 1, 2, 3, 4, 5, 6, 7 zeros here. Three zeros here and 2, 3 and 2 are 5 and 5 and 2 give you 7. So, this is the value I am getting here because this is the energy consumed in the 1 month we have. So, I can write it as 7.2 into 10 raised to the power 8. So, which is the correct option here? We are getting the answer that is equal to 7.2 into 10 raised to the power 8. So, the energy in the joules will be 7.2 into 10 raised to the power 8. So, our correct option is 7.2 into 10 raised to the power 8. So, these are the questions which are from your NTSE exams and that has been asked in the exam in various exams or the various boards of the NTSE stage 1. So, we have completed these questions. So, this lecture is over for today. We will start our new chapter in our next lecture. Thank you so much and have a nice day.